Okay, so hi and welcome. Okay, can you hear me?
Hi, sir. I can hear you very well, sir.
Um, so hope all of things will be well. Okay, so basically you already finished our total 7 days online training program. Yeah, and what's your best number?
Yes, sir. Pardon, sir.
Okay, okay, what's your best number?
My best number
Yeah, so it's seven best or eight
on what,
best.
sir?
Okay, just I
On
check.
what, sir?
Okay, I check it. Eight best number. Okay, so you are joined our nine best. Yeah, yeah. So you continue this online training program from the nine best. Yeah, yeah, yeah. From the nine best, and you also join our. You can see the WhatsApp group for that nine best. You can also including your name in here. Okay, so you are the nine best student from our institution, and you already completed the 7 days online training program on Google Earth Engine platform. Yeah, for the remote sensing analysis. And
Yes.
today is your problem solving. You face some problem regarding some issue. So I try to solve all of those issues for your problem solving. So I hope you can easily do all of those things. There is no problem. Okay. So first of all, you can simply share your screen and then let me check about your problem. Then I try to give you the solution. Yeah.
Uh, I'm not here with my machine, my laptop.
Okay. So now.
I'm just with the,
Okay. So now can you join
I'm
your.
with the desktop.
Yeah, so now can you join your desktop? Then it also better. Okay, so actually I can, or you can send me the code link about the problem. It also better. There is no problem. So you face the some problem on the land use land cover classification classes. Yeah, can you send me that?
No, that of land use and land cover I did it yesterday. I did not have any problem. The problem was at the level of the class, as we said. I
Okay.
corrected it until I send you a screenshot of what I did yesterday on land use and land cover.
Okay.
Now the issues that I'm having is that, yes, my issue that I'm having is that I did a land use and land cover May of 2003. I want to do land use and land cover for 3 days. Land use for 2003. So I want to use, I don't know how to use the same training data to use it for 2010 and the same training data, not to be doing. Imagine that you'll be doing genuinely, you'll be time taking and you might make mistake. So if there's a possibility the next year and just add where maybe there are some, for example, view up area that increases, just add, because with the traditional remote sensing, there's a possibility for you to update, yeah, upload them, yes,
Can you use the pen
from the
sharpening
Google.
the Landsat imagery? Then you can also reduce the resolution at the 15 meter. Okay, and use it for the pen sharpening. Okay.
Yes, so that is one of my, that is one of my problem. The problem is that since I'm working in a smaller region of interest, using higher resolution image will be difficult to identify feature. So in order to remedy that, I want to do a pan sharpie to improve the spatial resolution of my image
Yeah.
to enable me to analyze picture easily. So that's why I was facing issue on doing pan sharpening on Landsat 7 and Landsat 8. I
Okay, so
use some existing
I
code
will show you the process for the pen sharpening and also send you the code. So that's why you can easily use the code for your own region. Then you can easily make the pen sharpening and also reduce the resolution. Okay, so just I simply
yes,
share my
my
screen.
first, I don't know how this,
Okay, just I simply share my screen. Just a minute. So let's go. I just simply open my code editor. So mainly pen sharpening when you want to do using the Google Earth Engine platform. So here I already write the code about that. or I simply search here.
Hello, sir.
Yeah, please. Okay, just I find it that. Try to open a new code editor. Okay, just I simply open that code for the landscape pen sharpening.
Landsat 7. So Landsat 7 and 8.
Yeah, both
Is it
of
the
things is
same?
the same approach.
Okay.
Okay, just I show you the process for the landscape 7 and landscape 8.
Okay, sir.
Okay, just I click the run. So this is the region of interest. So any region, you can use the code for any region. There is no problem. So first of all, you can check the
Okay,
result
sir.
about that. So in this time, yeah, we can get the two types of images. So two layer you can see. One layer is showing that pen sharpened and also showing the original. Okay. So basically in this time,
Yes, sir.
for the original is the 30 meter. Okay. But when I apply the pen sharpening technique, then this resolution will be 15 meter. Okay. It increasing the resolution. Okay. So you can see the original image.
How?
It look like that. It's the original image. Okay. But when I apply the
Sir,
pen
please can you check?
sharpening, then I can get the very high resolution imagery. You can see the difference between the two images.
Hello, sir.
Yeah, please.
How do we check it to know that whether it's 15 and the original image is 13? How do we inspect it?
Okay, it's the original image means that the Lancet 8 imagery. We cannot apply the pen sharpening technique. And the another layer is that we say apply the pen sharpening technique. Okay. So in this time you can see this is the image. So in this time I show you the both of images. So that's why we can easily identify the difference between the pen sharpening technique and without pen sharpening technique. You can see here it's the original image, but when I apply the pen sharpening technique, I can get the image look like that. You can see it's the pen sharpening image. Mainly it's the increase the resolution. It is the original, and when I click on here, I can get the result look like that. Okay, basically this is the difference between the two images. And now how it will be worked for the pen sharpening technique. Okay, so mainly pen sharpening technique
Yes.
is the process for increasing the resolution. Okay, So mainly this pen sharpening technique is the process. Now how it will be work. So mainly pen sharpening method, there are the five fusion method for the which close to the create the pen sharpening images. So the fundamentals of the pen sharpening technique is that, so I simply explain some theoretical part about the pen sharpening. So pen sharpening mainly uses for getting the result for high resolution imagery. Okay, so in this time pen sharpening you can easily use the Lancet imagery and then get the high resolution imagery about that pen sharpening. Okay, and pen sharpening uses a high resolution pancometric image. Okay, it is a high resolution pancometric image or raster band to fuse with a lower resolution multiband raster data. This result mainly produce a multiband raster dataset with the resolution of the panchromatic raster. Okay, and pan sharpening is a radiometric transformation. It is a radiometric transformation available through a raster function from the geoprocessing tool. In this time, we are using here the Google Earth engine. Okay, and mainly in this time pan sharpening method, there are the total five method for the pan sharpening. Okay, the five image fusion method from which created the pen sharpening images. So in this time here I use the mainly intensity, hue and saturation. Okay, so intensity, hues and saturation, it's called the I. Okay, I write some comment in here for the description. So mainly in this time I use this method is that I ace is. Okay, so what is the I means that it's mainly showing the about the intensity. Okay, I for intensity, is for hue and S for saturation. Okay, so what is the I for, I simply write that intensity and S for hue and S for saturation. saturation saturation. In this time I use this technique and then apply in my images. Okay, and then try to find out the increasing the resolution. Okay, so first of all you can see here I show you the process in my code. So in this time here I can this is my study area. I simply import the study area as a boundary shape file and then simply use this code for removing the cloud. Okay, removing the cloud from my satellite images. Okay, and here I use here this, you can see pen sharpening of Lancet image SSV. Okay, so in this time S is that hue saturation and V for that intensity. So in this time what can I do? For I take a variable. In this variable I simply set here the RGB. Okay, take a variable name RGB and select the RGB band combination, mainly red band, green band and blue band. B4 is the red, B3 is that blue and B2 is that green. Okay, so after that I also use here the B8 band. Okay, so mainly it now it is the panchromatic band. What is the band 8? Band 8 is the panchromatic band. If you want to simply copy that, what is the panchromatic band? Suppose I can simply copy the image collection, and then paste here. So here I can get all of those band details. You can see I can find out all of those band details and you can see the what is the B8. Okay, mainly B8 is the panchromatic band. Okay, you can see what is the resolution about the panchromatic band. Panchromatic band resolution is the 15 meters. So in this time I use here the panchromatic bands and this resolution the 50 meters. So when I use this band and make the pen sharpening, then it will be final resolution will be 50 meter because my panchromatic band is the 50 meter. Okay, so I simply select the B8. B8 is the panchromatic band. I simply select the B8 is the panchromatic band and the panchromatic band resolution is that 15 meter. Okay, so after that you can see what can I do. Just I simply convert the SSV swap in the pan band. Okay, convert to the back RGB. So for that I can simply use a call the RGB. This variable I simply call and convert it RGB to SSV. Okay, and then select hues and trans saturation. After that I use at the get function and add that. So basically in this time, here I use the RGB and panchromatic band, then this convert into HSV, okay, for showing the band. So this is my function for creating the band sharpening technique for Lancet 8. In this time, suppose you want to use the Lancet 7, then what you can do? Same process, just simply change the band name. Okay, so you need to find out what is the panchromatic band for Lancet 7, what is the RGB band for the Lancet 7. Just find out the band name and put here one by one. Okay, then all of those things will be same for the function, for panchromatic function. Okay, so I hope you can got my point about that. In this time it's showing the Lancet 8.
Yes, sir.
Okay, but when you want to use the Lancet 7, just find out the what is the panchromatic band of Lancet 7. Suppose you want to work for the Lancet 5, you have to find out what is the panchromatic band of Lancet 5, then put the band name in here, and also select the RGB band. RGB means that what is the red band for Lancet 7, what is the green band for Lancet 7, what is the blue band for Lancet 7. Find out and put here. All of those things will be same. This is my function which created the pen sharpening. After that, it's a variable name. You can see this variable name. I just need to add with my image collection. You can see I simply add that using the map function. I simply add my image collection. So now it will be what? I simply show the result. You can see I can get the two types of this layer. It is a pen sharpening, and it increasing the resolution as a 15 meter because my panchromatic band is 15 meter. Okay, so now I use this image better and I can easily identify all of those feature, all of those things. When I want to do using this image, I can get the better quality image and use the different types of land use, land cover, or NDVI or other things. Okay, so I will send you the code link
Yes.
also with you. You can simply try to make the panchromatic using the Lancet 7 or Lancet 8 for your region and then check the result. Okay, then if there's any problem, then I also help you. There is no problem. Okay.
Okay, sir. Thank you.
Yeah.
Sir,
And any question?
thank you very much.
Yeah.
Yes,
Okay.
sir.
Okay. So I
So
said
I
you
have
that
also
you also try to
difficult.
practice. Okay.
Yes, sir. So I have also difficult in doing. You know, when you are working with Landsat image, Landsat image as from 2003, they have a scan line. So to remove the scan line on Landsat image using
Oh,
Google
okay. Yeah.
Earth
It's
image,
it's a good
can
question.
you
Yeah. Yeah.
also
Yeah.
tell
Yeah. 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 Yeah.
me?
Yeah. Okay. Just I understand about that. In this
Because
term, you talk about the gap filling or scale line error. Yeah. So scale line error or
yes, sir.
gap filling,
Yes,
how
sir.
we can easily handle that? It's very good question. And mainly we can face this problem for the Lancet 7 or Lancet 5. We can get some scale line error, or we can also find out some error line on the satellite images. But we can easily remove this type of error line in Google Earth Engine platform. Just a minute, I show you the process. For the okay, just suppose again the Lancer 7. I simply open that. Because this Lancer 7 I mainly use for the making the LST. Okay, so when I click to the run, I can get the some scale line error for the Lancer 7. Okay, so I want to make the LST map using the Lancer 7. So for that, first of all, I need to remove this type of error. You can see in this time it's showing this only for that this type of line I can find out in here. But when I apply here the gap filling function, then I can get the very better quality images. Okay, then use this image and make the LST map or any other remote sensing work we can easily do. There is no problem. So as I show the process. Okay, so in this time it not need. I just simply show you the image how we can use the gap filling process and fill the and get the better image. Okay. So in this time, here you can see this is my study area, and it's my source image. Okay, source image means that it's showing the about the specific image for my region. Okay, but it not cover my whole region. Okay, it not cover my whole region. I can get the some gap, and also you can see the simple. It also not cover. Okay, in this time here you can see when I simply increasing this side, here I can get some line error. So you can see here I can get the some line error. Okay, but when I open the median image, then I can get the better. So now how it will be work? Okay, so mainly when you want to work for the scale line error or gap filling, there are a lot of technique. There are the lot of techniques are available. So in this time we work with the kernel size. Okay, so we need to work
Sir,
with the
I'm
kernel
not clear.
size and put the kernel size as a 10 meter. Okay.
Sir, I can't see your screen.
Okay, just
Hello,
a minute.
sir.
Yeah, just okay, just a minute. I simply yeah. So just I simply stopping the sharing and then open it. Then it's a better. Just a minute. So now can you see it?
Not yet.
Yeah. So now it's showing. Yeah.
Yes, sir.
Okay. So now here I can use this kernel size technique. Kernel size. So basically, using the kernel size, how we can easily fill up the gap from the satellite images. So this is our code only for the kernel size. And now I explain how it will be work for the kernel size. So basically, this is the code which I selected. This code we need to use the make the gap filling using the kernel size. Okay. So in this time, first of all, I simply take a variable kernel size. In this kernel size, I just put here the 10-meter kernel size. And you can see here I use a function e.kernel square. Okay. I simply go to the docs tab and try to show you that what is the meaning about that function. You can see the e.kernel.square. Yeah. So this function we are using for the make the kernel. So in this time, generate a square shape boolean kernel. Okay. So mainly this function generate the shape. Okay. Generate the shape. Okay. So in this time here I put the kernel size is the 10. Okay. 10 into 30. Mainly 30 is the resolution of your satellite images. In this time it is a Landsat image. So I use here the 10-meter resolution. And it is a unit. What is the unit? Unit is a meter.
So
Okay,
why
meter
10?
size. Okay, so in this time, for my gap, my gap size one to another. This size is the 10-meter. Okay, suppose I can some gap, and this gap distance is the 10-meter. When I use at the 10-meter, then it will be fill up very better. Okay, it's not a constant value, but in this time for the 10-meter, my gap is fill up. Okay, mainly kernel size is the distance between the two gaps. Okay, this is distance between two gaps. So when I use it at the 10-meter, then it will fill up. Okay, so now I want to create the shape. So how I can create the shape? I need to use the function e kernel square. Okay, then put here the kernel size. I already defined the kernel size, and also put here the resolution of my satellite images, and put here the unit of the resolution. It is the meters. Okay, then false as a boolean, we can simply use as the false. There is no problem. In this time, after define the kernel size and also make the shape, we have to follow make the gap fill. Okay, so this is the full code for the gap fill. Full code for the gap fill. So now how it will be work? Okay, you can see first of all we have to create a function variable name. Suppose I put the function variable as gap fill, and then use the image as a element name, and this is my curly bracket start and this curly bracket end in here. In this time, first of all, start image date advance past year. Okay, past year. or we can say that about that pre. Okay, it's a pre, and then after. Okay, so a star, I take the advanced pre-year, and in I also take for that after 1 year. Okay, so that's why I use that the negative one and positive one. Negative one means that pre, and one means that after. Okay, so then what can I do after started in that? Then take a variable fill, Landsat 7 ls. Basically, I already defined the Landsat 7. You can see here I already defined the Landsat 7 ls. So simply call the ls, then put here the filter date, start and end. Okay, between the pre and past, and make the median composite. Okay, then use the regress. I simply call the fill. Fill, this is the fill. Add a bands with my image, and then I simply use a regress also and select the band name and short. And now how I can fit it? Okay, so I need to fit. How I can fit it? For fitting, here I use the reduce neighborhood function. Okay, so mainly reduce neighborhood function, it mainly create the some pixel value. Suppose I have a gap, this gap pixel value I don't know, so then it collect the pixel value from the neighbor image or neighbor side pixel value. Okay, so use the reduce neighborhood function, and in this time we apply at the linear fit function for each images with all of those band. And offset is the fit, scale is the offset, and scale is the same. All of those things will be same. Okay, so basically this is the function for the gap filling, and this function is for your gap size, and also create the shape. After that, I simply copy the variable name, and this variable I just simply add with my collection. You can see I simply add with my collection. So I just simply copy this variable name and then add with my, you can see I use the map function. Okay, use the map function and use the gap fill. Okay, basically this is my function which I created. This function I simply add with my image collection. So just use here the gap fill and from the median and click with that. So after that, when I open this image, then I can get the very clear satellite images in here. Okay, so basically this is the full code about that, and mainly gap filling code. You can see it will be start from here. I just simply copy it, suppose this code, and also from here. Okay, yeah, yeah, it will be finished in here. So basically this is the code. I simply open a new code editor and try to open the code only for the gap filling code. So then you can easily use this code for any other region. When you face the problem, sometimes you can use the 10-meter kernel size, and it did not fill up. It did not fill up the your gaps. Okay, then you have to increase the kernel size. Okay, so kernel size is not
Okay,
the
sir.
fixed. Okay, in this time for my region of interest, the 10-meter is the okay, because one gap to another gap, this distance is the 10-meter. Suppose sometime this distance is also high or also low, then you can use it for the other number. There is no problem, it's not a constant value. Okay, so in this time I can see the code in here. So you also try to use this code for your own study area and try to show the result, what type of result we can get. Okay, so basically this is the result for that using the kernel size. It is a one method for gap filling on the Landsat 7 satellite images. So you try to use the code and also try to use the pen sharpening code for your region, and then check. Face any problem, then also let me know. I hope you can also get the supported. Okay, there is no problem. Yeah. So any question you have, you can ask me. Any
Thank
question?
you, sir.
Okay. Okay. So
No, sir, sir, is it possible to create this network?
okay. Okay. So I send you that. You can also try to practice and face any problem. That let me know. Okay. Okay. So any question?
No, sir. Okay, sir. Yes,
Okay.
my last question was how it was on the land cover that you have already generated your training data for 1 year, and you want to use the same training data for the other year. So how can you solve that?
Okay, for the land cover data set, in this time without checking the code, I did not talk anything, because in this time I have to check the code for your what is the problem on here. So then I can easily get the solution.
No,
Yeah.
so my problem is that, Nasser. Hello,
What's the
sir.
what's the problem? Yeah, please.
Yes, I want to do a land use and land cover for three time period, 2000, 2010, and 2023. I have already generated training data for 2000. So I want to use the same training data for 2000 to train for classification of 2010. How can I do in such a way that I should import my training data to the image of 2010?
Okay. So in this time you have to take the another training point for the 2000 and 2010. Okay. And for validation, in this time you can use the some data. Suppose you take the data set, and this data set you can simply divide. So you can use here the 20% data for test your model and 80% data for train your model. Okay. For checking the validation. It is the another technique. Suppose in this time you can see here, suppose when you want to make the land use land cover classification map, suppose present time 2023, you want to make the land use land cover classification map, then we can easily get the ground truth data from our field. But when you want to make the land use land cover classification map for the year of 2000 or 2010 or past year, very past year, then how we can get the ground truth data? Then we did not get any types of ground truth data. Okay, then we have to use the another method, and this method is that we can simply divide the data set, test and training. Okay, so then from that we are use the train data for train our model, and test data for check the validation or check the accuracy of this model. Okay, so I already talked about this topic on our 7 days online training program. Okay, so if you want, you can also check the video, then you can easily get the solution. Okay, for the I think it's the 6th number of class for the how we can easily divide
So,
the test and train data and make our analysis. Yeah.
so my problem is not that. My problem is at the level that, so this is my problem. I've already generated the training data, that is ground control point, region of interest. I've already generated the region of interest for the image of 2003. So I want to use the same training data that I already generated to use it for image classification of 2010. How can I do in such a way that I should import the training data that I have already done for 2003 to do the classification of 2010 with it?
Okay, so do you have collected the ground truth data? Yeah.
Yes,
Okay, for the
for
ground truth data.
2003, I want
Okay,
to do
for that you have
run
to
analysis
import it.
for
You have to
2010.
import it the ground truth data using the in here you can see the Excel file. Okay, you can see CSV file. Okay, from here you have to download imported the ground truth data for each classes. Suppose you want to collect the ground truth data for water, you can simply import that using the CSV file. Okay, and then use the data for train your model. Suppose when I click on here, you can see I simply select my file with my CSV file, and you can see the add property function. Click the add property, and then put the property name, suppose class, and set the value for water, suppose 0. Then upload it. Okay, so then all of those water training point, this level will be 0. Okay, same process for the other classes. Okay. Okay, so you also try to do that,
Okay, sir.
and face any problem, then you also just you can simply share your skin from your laptop or computer, then it also better. Okay, for getting the idea or getting the problem solution, it's better. So next time when you face any problem, just for the problem solving class, simply open your laptop or your computer, then I can easily understand about the problem. Okay, so in the meantime I send you the two code, pen sharpening, and also send you the code for the gap filling. Okay, you can just try to use the code for your region and
Okay.
then check the result. Okay. Okay.
Thank you, sir. And the record,
Okay,
sir.
thank you.
So do not
Okay,
forget to
thank
send
you.
me this record.
Okay, okay, thank you. I send you now. Yeah, thank you.
Oh,
Okay, have a good day. Okay, bye.
thank you, sir.